Good day. Welcome to our first talk of the remote screen. The talk will be best practices for British and English code. By Ernesto Arbitrio. Okay. All right. Welcome to the first talk of the second in the remote session. The first talk is best practices for British and English code by Ernesto Arbitrio. His bio is he builds analytical software products for a living. He stopped programming in 2008 and speaks at various PyCon conferences. Aside from his professional projects, he also invests in various personal projects such as Histolab, digital pathology, image processing, PyTest runner, studio extensions, Berkeley, and well, we look forward to your talk.
Thank you. So, can you hear me, right?
Yes, we can hear you.
Okay. So, welcome everyone, and well, let's get started with this clean code journey. Thank you so much for attending this talk. I am Ernesto. I am a software engineer at YouGov, and I am one of the PyCon Italia organizers. I'm passionate about coding, computer science, obviously, and cooking and food in general. So I'm Italian, so it can be pretty obvious, probably. Well, why this talk? This inclination on writing clean code started when I wrote bad code, when nobody cared about reading the code, testing the code, and basically having an actual code. So I decided to quit my job, change the job, and start learning the motivation behind the clean code. And like so many others, I stepped into Uncle Bob and all his books about clean code, clean architecture, and agile software development. So what is clean code? Well, by some definition, a clean code is a code that is readable, maintainable, elegant, and testable. And as a consequence, all these things probably make it hard for bugs to hide. I think there is not a single definition that states what clean code is, and it's more or like some points of view, in my opinion. And I'd like to show you two sentences that I think they are very representative for this topic. So the first one is from Grady Butch. He's one of the inventors of UML, that states that clean code is basically a code that reads like a well-written prose. Well, I find this sentence like the rule of the thumb. So if you think at some code and you're reading it, and you can go through all the code portion without going back and forth, well, that code has all the rule to be a good code. Clean code always looks like it was written by someone who cares. Well, this definition is the one I like the most. So if you think that, okay, I care about something, and if you care about the code, and if you care for who will read the code after you, you should write a code that is clean and readable enough for all the other contributors that will write code after you on same code base, for example. Now I'll try to give you my point of view. How the code is written, in my opinion, matter a lot. Because when you are new in a project, so you don't have any strong knowledge on the context. And when you read the code for the first time, you rely on it, right? So, and you have to rely on it. So it has to be readable enough to dive you deeper and deeper in the code from time to time. So we have seen some we have seen some clean code definition, right? But how can we measure it? I mean, is there any possibility to use a metric for measure the cleaning of the code? Well, Uncle Bob states with this clean code measurement that says that the only valid measurement of code quality is WTFS per minute. Well, I've been in both sides of that door. And so I decided in this talk to talk about this concept that is reduce the WTFS per minute. And I'd like to share with you some rules I use for accomplish this goal. I mean, these are the rules that I'm gonna share are not all the rules that I use because it's very complicated to shrink all the clean code techniques in 30 minutes for 40 minutes. So I'll try to mention some basic concept as a starting point. I think that the time spent reading the code versus writing the code is well over 10:1. So if you want your code to be easy to write, you have to make it easy to read. Because when you start a greenfield project, for example, and you start, coding and your productivity is great, you can add feature on top of feature, and for a short period of time, this is gonna work. But then, if your features start growing and you, realize that you need a refactor of a particular portion of the code, and you don't do it for laziness or for other excuses, your productivity will be asymptotically will go out asymptotically to zero in a few time. So this means that owning a sloppy code, it's gonna be not productive for from the time that you start growing software. So if you think that is from this topic from a company perspective, this is not affordable, because even if you put more developers on the team, it's barely impossible to maintain a messy code, because it's going to be difficult to implement new feature every day without starting from a refactoring and then using some clean code techniques. So in my opinion, this is also a mental health matter. And so what prevents clean code, the mindset of I'll do the refactor later. So when there is the possibility, the opportunity for a refactoring, don't say I'll do it later, because in my opinion, one of the most causes that prevents this from prevents a well-written code is basically this kind of mindset. And basically, this is what states the Boy Scout rule that we will see in a while. Well, let's take a look at this huge function that, in my opinion, is not readable. So we can see that refactoring the code into, for example, 3 separate functions, and then organize the caller to have a clean sequence of invocation, it can be a word. So it can be ready for writing tests in isolation and entail a better code. So let's see some basic but important rule for writing clean code, starting from the basics. Use descriptive names. Don't be scared about having long names. Nowadays, we have autocomplete in our IDE. So don't use a single letter name for a variable, for example. In few words, the name should represent the developer's idea. And in the code here, in the snippet on this slide, the name D is describing nothing. So instead of D, use a better name like day since creation. That is meaningful, and it states what the developer is gonna assign to that variable, a daytime, for example. Use meaningful names. Variables, for example, in general, should have meaningful names, because when we read them for the first time, we have to understand the intent of the developer. So in this case, the variable MODD, whatever, as a bad name for the simply reason that is not a meaningful name at all. Even if we don't know the context of the variable, we can understand that name is bad because it's basically, it's not representing anything. I mean, it's not meaningful. It's misleading in some way. So having a sort of hunch on the format in the name, like the capital Y, it doesn't give us any further information, right? So we can spot the format just like looking at the value. So a better name for that one can be modification date. That means something. Another important rule is that names should be searchable. Single or double letter names are hard to search in the code base. Abbreviation sometimes cannot be useful. So avoid using common words like sum, temp, or flag, as they seem to be used by a lot of methods and classes. Hence, they are not search-friendly names, in my opinion. So in this case, the variable that says ctx RSP dict is better if we call it context response. I mean, why we have to put a suffix that says dict? We can state that is a dict from, for example, the value that we are assigning. That is case is an empty dict in Python. Or maybe we can rely on typing if we are using static typing annotation or stuff like that. Class names, when we write class name should have noun or noun phrase as name, like, I don't know, customer, account. And a class name should not be a verb because we are stating an object. We are representing an object, a class that has something to be assigned to and contains methods. So that is an object that should be a name, unless methods should have verb or verb phrase names like post payment, delete page, save, whatever. But names should also say what they do. So looking at the example, you cannot tell from the call what the function method does. Right, in this case, it's this method add applied to the object date. What's adding? 5, it can be years, can be months. So that name should be more meaningful. Like, let's say add years, add days, add whatever, and that can be a real interesting name, and it's more comprehensive. So looking beyond the object names, we can also see how code can be bad if we use comments in the wrong way. Comments sometimes can lie. So code instead never lies. Taking a look at these two examples, in the first one, we are basically reading at the comment that says check from the stock repository. This means that the return values is relying on the stock repository object, but this is a lie. This is false because maybe someone refactored the code, changing the stock repository to billing repository, but it didn't change the comment, and so this is a lie. So this comment is wrong. On the second snippet, if you take a look at the code, it's very simple code. Why we have to use a comment there? The comment is 100% unnecessary. The code explains clearly itself. Sorry. So other than that, comment can be lazy. Let's see a kind of lazy comments. So basically, a lazy comment, and then a comment can tempt you off the virtuous high road of the code refactoring and brings you down the easy path of describing sloppy code. The developer in this snippet here was describing with a comment something hard to understand instead of refactoring the code and get rid of the comment. In this case, we are describing something that is not readable at first glance, right? So doing something like this, maybe it's going to be more readable, and then we can avoid the comment. So we should not commit a crime every time. Using a comment to avoid programming effort is this crime that is going to basically bring you to sloppy codes in a few times. So instead of using comment for explaining bad code, you should make it better. So I would like to share with you some other interesting rules on clean code. Code, in this case, so methods or functions should do only one thing. So let's discuss what is only one thing. Only one thing basically means that this function should basically, in this case, return only one value, or basically rely on only one object, only one query in this case. So this function can be difficult for any developer to understand, probably, but more difficult will be to test that function. So in this case, your function should do only one thing. And if you follow this rule, it is guaranteed that they will be small and testable in isolation, and then you can just write unit tests for that. So the only thing that function does should be stated in its name. So looking again at the function name, the first one, for example, even the name is misleading because it states retrieve flight info, but what's the info? Maybe it can be retrieve flight number and passengers, or other information about the flight. I mean, it should be very precise, not general, because it can be misleading for who's going to read the code after you. So a better implementation of that one can be to split the function into two functions, and then retrieve flights, retrieve passengers. So we know that the first one is going to retrieve the flight, maybe with all the information of the flight and the passengers. And then the caller can be my flight, so retrieve flight A whatever, and passengers is going to be retrieve passengers and whatever. This is more readable. This is more precise and more testable, in my opinion. Well, so how can we define, or better, how can we check if that function is doing only one thing? A simple method would be continue to extract, start to extract and continue to extract part of the original function in another function. So if you can find a way to extract something from the function that is going to be another function, that means that that part of the code should be in a different function. Once you cannot do extract anymore, you could be sure, or almost sure, that the function, or the method in this case, is doing only one thing. Looking at the code, obviously we can extract a lot of things from there. So just looking at the number of the lines, it's a huge method. Maybe it can be split into three functions, and then having the caller that calls each different function, and then think about testing this one versus testing three different small functions. And so speaking of keeping things small, we should introduce the concept of cognitive and cyclomatic complexity. We should also avoid having big cognitive and cyclomatic complexity. The cyclomatic complexity determines how difficult your code will be to test. On the other hand, the cognitive one tells you how difficult your code will be to read and understand. Obviously, we do not calculate the complexity of the code by hand or determine the grade of the complexity just looking at the code. We have tools for that. For example, Flake8 has this feature. It can throw some raise warning when you run Flake8 against your code. So it's going to be very useful to, for example, keep this function, this post comment, into a more small code and less complex code like this one. So in this case, in this previous case, the cyclomatic complexity is going to be like 6 because we have 6 steps. And in this case, we are gonna run a lot of tests for checking that one, or maybe we cannot understand how many tests we have to write for all these branches in this case. But much more easier to read is having something like that with the complexity of a both function is 1. So by knowing how many code paths there are, you can know how many paths you have to test. So the first advantage of measuring software complexity is to have a better test coverage, because as a result, you'll have an idea of how many tests are required at minimum, and then ensure that the code is well covered by tests. Sorry, it was a mistake. The second one, not the third, is low risk. So I stated that it's harder to read code than to write code, right? And for sure, code is read far more than is written. So a good software developer should never be assessed by the lines of code they've written or changed, but by the quality of the code they maintained. This can reduce the risk of misinterpretation and so make your code quality higher. And obviously, having the perspective of the complexity can reduce the costs. For example, for fixing bugs, with a higher complexity, fixing bugs, it can be very hard. Reducing the complexity can reduce the cost, obviously. Another rule I would like to share with you is the law of the Demeter, or more known as the only one dot. So basically, this law states that a function states that a method M of an object A may only invoke the methods of A itself, methods parameters, any object instantiated within the method itself, A's attributes, and global variables accessible by A in scope of M. But more easy to understand is that, for example, if we have an object book, we should avoid to call methods on top of methods on top of methods, like book.pages.last.text. So the law can be stated like more simply like, okay, use only one dot. As an analogy, we can represent this rule as a when you want a dog to walk. So you don't command the dog's leg to walk directly. Instead, you command the dog, which is the command which then command its own legs. So basically, if you read the code and the snippet, it's more easy to read the second part where we say dog.move. And then if we want to know the internals of that move function, we know that the move internals is basically iterating over the legs and move the legs themselves. Rather than moving the leg.move forward 3, we don't have to do that, because the advantage of following this rule is that the resulting software tend to be more maintainable and adaptable. Since objects are less dependent on the internal structure of the other object, the object implementation can be changed without reworking their colors, for example. And so we can avoid coupling or better tight coupling. And in this law, I can see just one obvious drawback, that basically the objects, in this case the dog, can grow because we add new methods to avoid coupling. And then on the other end, the methods and the color can be small enough to compensate the class growth. So we have to, find a compromise on that. Well, another aspect I would like to focus on is that we should avoid premature optimization. As Donald Nutt states, basically premature optimization is the root of all evil. Because why we have to spend a lot of time on something that you may not actually need today, okay? So a classical example of this is a startup that spends an enormous amount of time trying to figure out how to scale their software to handle millions of users, unless they should start validating user feedback and try with, I don't know, 100 users. So in terms of code, you should avoid adding features that are probably needed in the future, because this can create confusion and reduce the productivity. When your startup grows, and then you need your software to scale up to 1 million, then you have to reorganize the work, not only in terms of software, but only in terms of reorganization of the structure of the company itself. And furthermore, another thing that I found personally useful is the concept of the continuous refactoring. Well, continuous refactoring is the main principle. This underneath that is you have to constantly refactor constantly, without mercy, to improve the design of the code. So this concept is also known as the Boy Scout rules, that says that you must leave the playground cleaner than you found it. So, for example, if you are refactoring a code that has been written by one of your colleagues, and you think that that code can be written better, but not better in terms of performance or other perspective, but better in terms of readability, you should do that. You should do that for the sake of mental health of the future developers. So in my opinion, this should be a cultural change, and company should understand that this approach could reduce the technical debt every day. And all these rules, obviously, I gave for having clean code, and especially when you do refactoring, cannot be applied if you don't have any test in your software. So in having a good code base and a clean code base, you have to test the code. Why this? Because if you apply, for example, the concept of the continuous integration, continuous refactoring, how can you be sure that changing some code, all the other things are still working if you don't have tests? So tests are absolutely mandatory to have a clean code base. And these also falls into the bucket of the caring. So if you care, you need the right test, especially if you care about who is reading the code after you, because who is reading the code after you is going to rely on the tests and reading the test first before reading the code. So when you ask yourself if your code is clean enough, or is readable enough, or does it have tests, etc., you should check if your code has a smell. So, what I've covered today is basically 5% of the topics underneath the clean code word. And I think that probably each of these topics can be a whole talk itself. But I think it's going to be very hard to shrink all this stuff in one single talk. So for any other information, you can ask me questions. Thank you.
Right, thank you very much.
Thank you very much.
I don't see any questions, remote questions at the moment. Are there any questions from our audience?
Hey, Ernesto, use this one. Hey, Ernesto, thanks a lot.
Thanks a lot. That was a really cool talk.
So
Thank you.
the law,
Demeter,
Demeter,
it's an interesting case when you
I do a lot of data work,
and I use pandas obviously quite a lot.
And method chaining is very common, and it's quite a common pattern in the pandas world. And I'm wondering, just, is it okay because more often than not we're returning the same data frame slightly modified, or what's your thoughts around that?
I missed part of the sentences because your audio is cracking. I cannot hear you. I'm sorry. I can hear a lot of noise. Hello?
Can you hear us?
Now I can, but
Did you hear the question?
part of, not the whole question.
All right, okay, well, yeah, well, I think it's important specifically my question was about method chaining, which is very common in the data worlds,
Library, you often do it. What you're thinking about that in relation to the law of Demeter, and
Yeah.
is it maybe something we should be doing less of, or how should we be thinking about it?
Yeah, I think you're referring to the pandas library, right? So I think it's okay. I do love applying the law of Demeter whenever it's possible, but if you use pandas, it's basically impossible to avoid using the single dot rule, because sometimes all that stuff is basically coming in place and changing the objects in place, the data frame itself, and it's I found it very annoying because every operation that you run against pandas, it cannot be predictable at all. So in my job, even if I have to use data operation on that, I will, every time as a team, we write helper or wrapper on top of some pandas operation we need. But we also avoid to use that kind of stuff in production because we found that it's gonna be very flaky when you run some operation on large amount of data without any predictable finding. So if your question is what about low Demeter on data libraries, I think that there is something that is gonna someone is gonna do something better than having all that stuff wrapping together.
waiting to see if there are any further questions. Doesn't look like it will be more questions, so thank you very much for a very interesting talk. Thank the speaker.
Thank you.